Hey guys, just got this battery in for review. It's a 12 volt 100 amp hour from GreenOE. It's another brand I've never heard of before, but it came up on Amazon as a lightning deal, which is a limited time promotional offer. It was selling for $104 and I thought, hey, this would make a pretty good video. So let's see what we got. Once again, we have the same standard plastic case with M8 terminal bolts and a carry handle. You guys wanted to see a weight in the last video, so here we go. We're at 22 pounds, 3 ounces. The pamphlet that came with this battery is very basic, but you know, that is okay. This has a max charge rate of 50 amps and a max continuous current, which I assume is the discharge rate of 100 amps. I did notice the brand name GreenOE is not mentioned anywhere. However, it does reference Hublion batteries, a different brand in 2 different locations. Also, it specifically calls out to always ensure proper torque values, but there is zero mention anywhere in this booklet of what the proper battery terminal torque should be. I ran a capacity test on my American Reliance electronic load at a 0.2 C or a 20 amp rate. It was close, but it technically did pass at 100.27 amp hours. One thing I found particularly interesting with this battery is that it was delivered with a full charge. I plugged in my charger and, you know, less than 5 minutes it shuts off, and I was sitting across the room and I heard the fan stop and I thought, uh-oh, something must have gone wrong, but I came and checked on it and no, it was full charge already. So perhaps that was just their way of balancing it, but typically batteries don't ship with a full charge. I think there may be some regulation about that. Alright, so here's a quick look inside before I remove anything. We have a pair of number 8s for the negative. We have a single number 7 for the positive. The negatives are going through the BMS, and man, that is a tiny, tiny BMS down there. Alright, so as you can see, I didn't get very far here. I pulled back the little protective boot from the positive terminal here, and you can see down there it is a nut. But look at this. Look at that, it's not even tight. I can move it with my finger. That is not tight. That's not a good connection. But yeah, that's definitely a hard fail from my perspective. Guys, the negative terminal is the exact same way. It's not tight, it turns. Look at that, that is not good. That's not tight. Ooh, long cells. Had a bit of an incident here. While I was flipping this battery around on the bench, the balance lead, I think what happened is it pressed against the edge of the BMS here and some of the wires burnt up. So I will ask that you disregard the melted status of the conductors here. That was entirely my fault. The form factor of these cells is quite interesting. I've not seen these blade style cells before. I'd say they're just over a foot in length. The connections between the cells are quite interesting here as well, and it's nice to actually see something different for a change. The negative terminal of the cells appears to be raised and insulated, and the positive is laser welded to what looks like the case of the battery. Like I don't see any terminal there. There's no raised terminal like we usually see, but you can see what I'm looking at here. There's a raised terminal for the negative and there's really nothing for the positive. The laser welds do look like they're done very well. We can see our balance leads where they were before I snipped them off. They are held down with a lock nut, and they are ring terminals with a double crimp, once on the insulation and once on the conductor. Taking a look at the main terminal here, the piece of aluminum comes up the cell and makes a 90-degree bend. It's insulated from the cell with some epoxy board. These cells are held together with 4 wrappings of strapping tape, and they do have some epoxy board separators to keep them insulated from one another. Another interesting characteristic of these batteries is that the bottom is completely exposed. There's no shrink wrap protecting the bottom. The vents are actually on the bottom. We have 2 different QR codes on the bottom in addition to a QR code on the top that was covered by the laser weld, and we have a sealed hole. The QR code says DG04NTP+, however, I googled that and pretty much every other printing on the cell, and I couldn't find a single bit of information or a single picture online about these cells. So I really can't tell what brand they are or find any information whatsoever on them. And there does appear to be a direct connection to the end of the cell. So if I put one lead on the negative terminal here and one on the end of the battery, I have the full battery voltage of 3.13. Additionally, if I put my meter on the ohm setting and I go from the positive terminal to the bottom of the battery, 0.5 ohms. So it does appear to be a direct path. The BMS is sitting on top of the battery, insulated with a layer of epoxy board. It's held down with 4 zip ties, 2 globs of silicone, and I think there's probably some adhesive pad under there. Let's snip it off and see. there is a thermal switch on the side of the battery. This is not a temperature sensor, this is a thermal switch. It will allow for over temperature protection. It will switch on at a specific temperature, but it is not a actual thermistor or a temperature sensor. Okay, so there's no adhesive underneath. It was just 4 zip ties and 2 globs of the silicone stuff. And once again, look how small this is compared to my hand. This has to be one of the smallest 100 amp BMSs I've seen on one of these batteries yet. Part number JWZN-930A. It does say 100 amp, so I assume one of those is charge, one's discharge, with a maximum voltage of 85 volts. Not a whole lot to see. Again, this is pretty much as basic as it gets. We have our resistors here for balancing the battery and our transistors for controlling that. We have probably a computer circuit up here that controls the BMS as a whole. And we have our FETs for controlling the charge and discharge. And we have what appear to be diodes over here. And again, unless I'm missing it, I don't see any resistors, any shunting resistors here for measuring current. So also, there is no temperature sensor or thermal switch on the FETs here. Typically, we see one running up the center to provide over temperature protection of the transistors themselves. So yeah, that's about all there is to see. All right, there we go, the GreenOE battery. Unfortunately, those nuts that were not tightened down are an absolute deal breaker for me. We're 0 for 2 on the budget batteries now. I do have a third one coming, so there will be a third budget battery here soon. You just never know what you're going to get with these budget batteries, and I was expecting at least one of them to be good, but you know, this is the second one now that has a problem. So on the plus side, if there is a plus side, this company did not cover the lithium shipping warning on the box. So let me know what you guys think. Hit that like button before you go, and thanks for watching.